Okay, so we have here a boy throws a ball in the air with a velocity of 7 meters per second when they are standing at the edge of a cliff 20 meters high. If the ball falls and lands at the base of the cliff, what is the velocity of the ball when it lands? How long was the ball in the air? So I've just gone ahead and made a quick sketch of the initial conditions. It's initially launched upwards at 7 meters per second. It's a 20-meter cliff, and then, assuming that it takes an approximately straight back down path, straight back down path. Okay, so we need to find velocity when it lands. How long was the ball in the air? Okay, so we have three things going on. We have a distance, we have a velocity, and because of gravity, we have an acceleration. So I'm going to start off with the equation that combines all three. So we have x final is equal to x initial plus v naught t plus 1/2 a t squared. Okay, so in this case, I'm going to say that x final is 0, x naught is 20 meters, plus we have the 7 meters per second times an unknown amount of time, plus 1/2 times negative 9.8 meters per second squared times t squared. Okay, and so, we can multiply these together, and we get, 4.9 t squared. We have something quadratic, and so when I solve this, I get two answers. I have t is equal to negative 1.43, and t is equal to 2.86. Right, so this answer here, that's the what that tells us is if the ball didn't start here up at 20 meters, but was instead thrown to the ground, or then if we say that the point where we get to, the time when we get to this point here is 0, then that means that it, going from here, or starting at the ground and being thrown upwards to reach a velocity of 7 meters per second at a height of 20 meters, that would have happened, 1.43 seconds ago. But that's not really important to what we're interested in. We're interested in this positive value, which says along this trajectory, starting from this point and moving forward, we have 2.86 seconds before it hits the ground, which is the second part. How long was the ball in the air? As for what is the velocity when it lands, for that we have that final velocity is equal to initial velocity plus acceleration times time, and we now know the time at 2.86 seconds, so we have that our initial velocity is 7 minus 9.8 meters per second squared times the 2.86, and when I throw that in my calculator, I end up with negative 21 meters per second. In other words, it's traveling downward at 21 meters per second when it hits the ground.